Hey guys, welcome back. Welcome back to my YouTube channel. I am Praveen Reddy. So in this today's class, what we are going to do is we are going to write a Verilog code. Actually, here we are going to consider some circuit. For that, we are going to write Verilog code in terms of the gate level modeling as well as the data flow model. Right? The given question is that write a Verilog code for in gate level and data flow model for the given logic circuit diagram. So first let me take some logic circuit diagram. For that we will write the program in terms of the gate level as well as the data flow model. See that I am going to consider the 2 AND gate, 1 OR gate. So let me assign the input variables A, B, C, D. The output variable I am going to assign as the Y. So let me take one more time. So for writing the another model, right? So just I am going to take the one more copy. Now I assure that guys, if you understand this program, you can write any kind of logic for any given circuit in terms of the data flow as well as the gate level modeling. So first we will try to complete the data flow model. So first we need to define the module. The keyword is module, followed by we need to give the module name. Right, so here the name is that I'm going to give some name circuit. You can give any name. So now we need to declare that what is the input port as well as the output port. As per diagram, A, B, C, D, Y are the ports. Now module does not know which is input, which is output. So for that module we need to tell these are the ports input. The keyword is input and output. So Y is the output, right? That we need to mention. So now we need to write the assign statement, because data flow model means everything in should be assigned statement. See that logic gate 1 is multiplication, right? Output AB. For logic gate 2, output equal to CD. Then finally OR gate, right? Addition operation, right? So AB plus CD. Now if you want to write in terms of the Verilog, it will not understand this operator. So for that we require the Verilog operator. So A ampersand B, it means for A into B. For C into B, C into D, it is required C ampersand D. In between that, if you observe here, we have the OR operator, right? So for that this is the symbol. Now see that if you write this expression, that is what we called as the data flow model. See that just same expression I am going to write here. Remember, so for any logic gate or logic circuit, you just write the final expression that you have to write in our program. That is what we called as the data flow model. So module is begin, right? Now somehow we need to end the module. So this is exactly we are calling as the data flow model, which we are writing in terms of the equations. That's very simple. So next question is that how to write the program in terms of the gate level modeling. Now one point to remember is that first from the diagram we need to understand how many logic gates we have. If you observe in the above diagram, we have the 2 AND gates, right? 1 OR gate is there. Right, now what we are going to do is in gate level modeling, we are going to have the gate primitives. Right, as we know that these are the predefined functions. Now what is the gate primitive for AND gate? A and the AND, small letter output followed by the input variable. So that is what we have the gate primitive for the AND gate. Now for OR gate, what is the gate primitive? Small O R. In bracket we need to write the output ports or variable followed by the input variable. That's it. Now as per the diagram we have 3 logic gates, right? Now we'll start writing of the program in terms of the gate level. Gate level means in terms of the logic gate. So first write the module, give any name for the module. In terms I'm giving logic. So now just write the input output ports. Actually module does not know which is input output port. So for that we need to use the keyword input. A, B, C, D are the we are using as the input that will be understood by the module. So using the output keyword, we are going to tell that Y I am going to use as the output. So once it is declaration is completed, now we need to call the gate primitives. Gate primitives are what? Predefined function in the Verilog, something like as include std attach. Now first logic gate we have, right? Second, third. If you observe the diagram, you will understand. So first logic gate, if you observe here, what is the gate primitive? And if you observe here in the first logic gate, and output followed by the input, right? But in the see that in first logic gate we don't know what is the variable for output, right? Without having the knowing the variable we can't write, right? So here at this point of time we don't know what is the output variable. So for that I'm going to assign some variable, let it be w1. So output variable is w1. Then what is the input variable for first logic gate? AB. Now if you observe here, nowhere in the module we have the w1. Now here what we have to do is we need to declare that, but you should not declare in the module, just you write after output value. So what we have considered wire, nothing but some connection, intermediate connection. So w1 we have taken, so that we are going to write in the unprimitive. Next go to second logic gate. Do we have the output variable? No, right? For second logic gate, just to take the wire, something w2. So w2 comma, what is the input for second logic gate? CD. That's it. The same thing we need to mention in the W2 in the wires also. Then only it will understand, otherwise it won't understand, guys. Now what is the third logic gate that we have? OR gate, right? So if you observe in the diagram above, third logic gate is the OR gate. Now see that we don't need to assign one more wire because already we know that output variable is the Y. So what is the syntax? OR, output is Y. What is the input variable? Output of the first logic gate, second logic gate, nothing but the W1, W2. Now see that wire we need to include but does not require to include in the main module. That point you need to remember when you are writing the program in terms of the gate level modeling. Now see that module declaration, then end of the module should be done. So if you are writing this kind of program, that is what we called as the gate level or structure level modeling. So if you understand this concept, I can assure that you can write program for any kind of the logic circuit. Thank you, guys.